Hello, lovely humans! Welcome to part 3, the surprise part, because I realize deriving the equation for area can take a little bit of time. So if you need a second example in addition to the parallelogram, welcome, and I'm so glad you're here. If you feel confident in where the equation for area comes from and you can tackle it on your own, awesome, very cool. Feel free to skip to part 4, which we'll be talking about how to use calculus to find area, and it will help us understand where the equations for area actually come from. Super awesome and very powerful once you can wield it effectively. All right, so in our second example of deriving the equation for area of different types of shapes, specifically quadrilaterals. I love that word. I also mush it up sometimes, so that's all right. Cool. So, sometimes, just like any language, it gets a little mushy, just like math. That's okay. Okay, so here is our trapezoid. So the properties of trapezoids are that A and B, these two sides, are parallel to each other. And typically, I want to say that C and D are equal, but we will leave it like that for now. I'll just write C equals D. Okay, so just like we did with the parallelogram, we are going to divide our trapezoid into smaller shapes and then add them up to get the area of the trapezoid. And just like I said with the parallelogram, we're going to keep this general and use variables instead of specific numbers so that when you tackle a trapezoid in your own life, then you can apply our general understanding to that specific instance. Okay, so just like with the parallelogram, we are going to divide this into some triangles and a rectangle. So here is our first triangle, and here's our rectangle. So I'm going to call this length X, and this H. We'll see why in a second, or you're probably like, I know why, because of the last example. So in this case, the area of our trapezoid, all right, can y'all see that? Sort of, okay, equals the area of triangle 1 plus the area of triangle 2 plus the area of our square. I'll move C because it's getting in the way a little bit. Sorry, buddy. Okay, so this is almost exactly the same thing that we did for the parallelogram, right? So we got this, no problem. So what we'll notice is that we are going to call this X and this H, and so since C equals D, we have the same thing that we had with the parallelogram where these two triangles are equal. So in this case, we can say this is H, and again, this is X. And so then we ask, well, what the heck is the distance here? What is the base of our rectangle inside this trapezoid? Well, X plus X is 2X. So this equals B minus 2X. Okay. And now we are going to plug in the equations for area of these two triangles. So the area of our trapezoid equals 1/2 times, I'm going to run out of room here, so I'm going to move this. Okay, so area of our trapezoid equals 1/2. This first triangle is just X times H, or well, 1/2 X times H, plus another one, 1/2 X times H, and we will move this a little bit. We'll write this here, and then plus the area of our rectangle, which is A, or well, okay, that's interesting. We'll table that for now, which is going to be, let me think about that. What do I want to include? Well, okay, we'll say plus A times H. Okay, so we don't know what X is. We want to get our equation in terms of a, b, and h. Let's just assume we're given h for now. So let's simplify this, and we'll say 1/2 x times h, so we get x times h plus a times h. And we can simplify that by saying we can pull h out because h is common between these two, and say h times x plus a. Okay, well now, like I said, I want to get rid of this x here because let's say I was given a, b, and h. I don't know what x is. So let's get rid of it. So I told you that the length of this is b minus 2x. So another way to say that, well, we also know that this width equals a. Pretty cool, right? So a equals b minus 2x, and I can use that to solve for x. And I'm going to do that. Where am I going to do that? I need this equation. So I'm going to erase this one. Okay, so if I know that a equals b minus 2x, I want to solve for x. So the first thing I do is I get x by itself. So I move, since it's a negative, I'm going to add 2x here, that cancels, and I add 2x on the other side. So I get 2x plus a equals b. 2x, let's minus a from both sides. 2x equals b minus a. X equals b minus a over 2, because I divide by 2. And so that is what x equals. Rad. Now I can plug that into this equation. So I get h times b minus, we'll say 1/2 b minus a plus a. Okay, all right, we're getting there. So now I want to distribute the 1/2, and I get h times 1/2 b minus 1/2 a plus a. That's interesting, because I notice that if I subtract 1/2 from 1, I get a positive 1/2. So check that out. Super cool, right? So now I have h times 1/2 b plus 1/2 a. Ho, we're getting close. And I'm going to erase this for our final result, which is the area of a trapezoid equals, well, if I have 1/2 multiplied by both of these, I can pull it out front. 1/2 a plus b times h. Boom! Pretty awesome, right? Where a and b are the lengths of the bases of your trapezoid, and h is the height. Oh my gosh, I just made that harder to read. Okay, so this equation will work for any trapezoid where a, b, and h have different values. As long as it's a trapezoid, this applies. So try applying this equation to a trapezoid where a equals 2, b equals 3, and h equals 5. I don't know if that will actually be a trapezoid, so maybe you should double check for my sake. Cool. All right, so that is our second example where we have worked through how we can get the area of a shape by breaking it into smaller shapes that we already know how to use. So whatever shape you're given, this will work. Just make sure that you keep track of basically how the shapes are related to each other and how you can simplify things. So also just make sure that we're not assuming anything. So for example, we have to know that c equals d in order for this equation to hold. But if it doesn't, then we don't have a trapezoid. So anytime we have a shape, just figure out those simplifications that we can make and we can find the equation. I'm not a huge fan of memorizing, so there you go. Now you can derive the formula. Cool. Let me know if you have any questions about this or the parallelogram. And now it's time for the coolest part where we use calculus to find the area. So check out part 4 and it will be super fun. Yay!